Alrighty, so we are going to go ahead and use our TI graphing calculator in order to calculate the probability that a randomly selected man in the US in 2004 weighed more than 140 pounds. Now remember that for this problem we have a normal distribution. The weights of men in the US in 2004 was normally distributed with a mean of 172 pounds and a standard deviation of 29 pounds. Now since we are dealing with a distribution, we are going to go ahead and use our second favorite button on our calculator for this stat class, the distribution button. So second vars will bring up our distributions. And we know we want to use one of the normal distribution functions. But which one? Well, we will always be using number 2 if we are calculating a probability. Never use number 1. In this class, we will never use that number 1 button. So just ignore that. You can either arrow down and hit enter or just type in number 2. To pull up our normal cumulative distribution function. Now we need to fill in the bits and pieces. To do this, it's much easier if you have the sketch of your normal curve with your mean and your standard deviations labeled, and if you've shaded in the area representing the probability we are trying to find. We want the probability that a man weighs more than 140 pounds. So we shaded in all of the area under the curve to the right of more than 140 pounds. So when we fill in these pieces here, what is our lower bound? What is the leftmost edge of the area that we've shaded? Well, that's the 140 pounds. Upper bound. What is the rightmost edge of the area that we've shaded? Well, that area is everything to the right of 140, on and on forever. We're not going to worry about what's the biggest man in the US weigh or any of that business. This is a theoretical curve, and so we are going to assume that it goes to the right forever. We have not said the probability a man weighs between 140 and some upper value. No, it goes on forever. But our calculator does not have a forever. We do not have an infinity button. So we just need to type in a ridiculously huge number. Good simple example, 10 raised to, there's our little caret symbol to tell us we are giving an exponent, to the 99. That's a 1 with 99 zeros after it, which is so outrageously huge that it might as well be infinity. Alrighty, go ahead and enter our mean and the standard deviation. Remember, a mean of 172 pounds and a standard deviation of 29. And paste this onto our main screen. Now, if you have one of those calculators that does not prompt you for all the pieces, then in the notes that you will bring to your exam, make sure you write down normal CDF, open parentheses, lower bound, comma, upper bound, comma, mean, comma, standard deviation, close parentheses. And then maybe remind yourself, if the upper bound is infinity, type in 10 and then that little caret symbol to the 99, just to remind yourself. Now, when you go ahead and hit enter and get that probability, it should match up with the area that you shaded in. Now, if you look at the area we shaded, that's well over half. So when we hit enter, we should get a number that's well over half. In fact, we get 0.865, blah, 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 which is about 87%. Not that far from 90%, a little less than 90%. So yeah, we shaded in most of the area under the curve. Not quite 90% of it. All right, as always, if you have any questions, please let me know.